Let's think about, we have this circuit here, and we have been given 5 resistors. We're asked to find RT, IT, which is standard, right? I3 and V5. And so I3 and V5. Okay, so let's start then by identifying series parallel branches that we can tackle. So you notice I haven't put any nodes or dots on this, but we'll assume that, wherever any two lines cross, that is a connection. And so the idea then is that, R4 and R5 are not in parallel because this one shows up in between. So R3 and R5 are not in series because the same current that goes through 3 don't go through 5 because of this connection here where current from 2 and 3 combines to go this way, right? And so remember then that you got to be very careful about your connections and about the series and parallel relationships. And so here the only relationship that we can identify is 2 and 3. They're left end connected together, they're right end connected together. 2 and 3 are in parallel. So we combine those first. And so then we start off by saying that R2 parallel with R3. The product over sum says 12 times 6 over 12 plus 6, which is 18, and that should be a multiply there, which gives us 72 over 18, or 4 ohms. Okay, so we can't really simplify any more past that, so probably we should redraw. And so I've taken the liberty of having that redrawn. So it looks like this. And so I should be able to grab that, pull it over to our original page. Oh, it comes out way too big, but I can make it a bit smaller. Okay, so there's our first redrawn circuit. And I guess that I should have called that our A. That's what Mr. Matcham told us to do, right? Start off with some letter subscripts. So you'll notice I've put in RA here at 4 ohms, which is our calculated value. Okay, so now when we look at this, right, remember R4 is still not in parallel with R5 because RA is in here. So R4 and R5 don't have the same voltage drop across them. But RA and R5 are in series. And so RA in series with R5 means take the linear sum, 4 ohms plus 20 ohms, and call that RB 24 ohms. Now, at this point in the game, you might realize that now we have found this resistance, which is between this point, and that is in parallel with R4. And so if you want to do that calculation because you can see that before you redraw us, by all means, that's a good idea. However, I have taken the liberty of redrawing that again. And so again, now, the more times that you redraw this, of course, the more time it takes you to complete the solution. And so the idea is that, you redraw it as much as you need to. And so that's less and less the more experience you get at this, right? Okay, so now I have included RB at 24 ohms. Okay, so now these two are in parallel. So we have R4 parallel with RB is equal to 24 divided by 2 because they're both equal now. And that gives us 12 ohms, and we can call that our C. Okay, so now you'll notice that I redrew this one one last time, which is probably not necessary at all to show RT there, but in any event now, I did redraw the one last time, and so now our calculation for RT then is to realize that, okay, so why did I do that? I wonder. So I think I'm missing a redraw there, because really I think this one here should have shown VT R1, and you can see now why I redrew them before I started this, but we should be showing R1 in series with RC, I think is our issue, and RC there is 12, and R1 over there is 12, and those two are in series, and so we should be saying, I think, that RT is equal to R1 in series with RC, means plus RC, and that gives us 12 plus 12, which of course is 24 ohms, and so RT equals 24 ohms. And then if you want to redraw that final one that I have there, well, that's totally okay too, but really, it's kind of important to show probably this circuit here more so than this one here, right? And so we got RT, and that is the answer to part A. Okay, and so now let's go with that it finishes our calculation of RT. And so now on the right side of our page, going back up, we want to complete the rest of the calculations. So we start off then with IT is equal to VT divided by RT, and we have 24 volts over 24 ohms, and so 1 amp for IT, and that of course was the answer to part B. Now next, concentrate on answering the other two parts of the question as we've been asked to do it, and that brings us then to I3 and V5. Okay, now I didn't put I3 don't show up on this circuit, but V5 shows up here. V5 is not on this circuit, and so the idea is that if I want V5, I need the current in that branch, which is IB, and so I can find IB, right? Why? Because I can find that IT here at 1 amps divides into these two. And so the idea now is that, remember, we combined them to give us 12. And so this voltage right across RC is the same as the voltage across RB and R4. So what we want to say is that VB is equal to V4 is equal to VC. And because this circuit here got IT flowing through it, then we can calculate VC is equal to IT times RC. And so that is 1 amp times 12 ohms, or 12 volts. So if VB is equal to 12 volts, then I can use that to find the current IB, right? And so IB is equal to VB over RB. And we have now 12 volts over 24 ohms. And so that gives us 0.5 amps. And as I guess, you might suspect, that current halves, because 1 amp comes in, there's 2 equal resistors, half it goes each way. So that means that now we can say for this circuit right here, IA equals I5 equals IB. Why? Because IA and I5 combined to give us RB. And so that means that this here is IB. And so if I5 is IB, then that will allow us to say now that V5 is equal to, by Ohm's law, I5 times R5. And that gives us 0.5 amps multiplied by 20 ohms, and V5 is 10 volts. And that is the answer to part D. Okay, so we're getting close to time there. We got 10 volts right here. And now, the last thing that we wanted to do is we wanted to find I3 right here. And so realizing now that VA is equal to V2 and V3, and we already got IA, right? And so up here now, we're going to say that VA is equal to IA times RA. And if I can go through that quickly, IA was 0.5, and we're going to multiply that by RA, which was 4, and VA then is 2 volts. And so again, remember now that V2 equals V3 equals VA. And the reason why that's true is that R2 and R3 combine to make RA. And so the voltage drop across RA we bring up to this circuit, and that is 2 volts. So if I want to find the current through R3 by Ohm's law now, I3 is equal to V3 divided by R3. And so that means that we have 2 volts over 6 ohms, and I3 came up to be 1/3, or 0.333 amps for I3. And that is the last one that we were asked to find there, which is now part C. Okay, so this current comes over here, and remember now that 1 amp came in here, half of it went this way, the other half divided into these two resistors, with the smaller resistor getting more of the current, the bigger resistor getting the remaining part of that current, which was the other 0.166 or 0.167 amps to make up the 0.5, right? And so that makes sense to us. Okay, so